Okay, as you look at this one, probably thinking that both sides look relatively complicated, right? Okay, but if I had to venture, and say like which one would be more complicated than the other, this one it just has signs in it. All right, nothing squared. The left side has a cotangent squared and a cosecant. So overall, I think it would probably be there'd be more to be able to work with the left side because you have a portion that is squared, and you also have cotangent and cosecant, which we can just generally work with a little bit more. It'll be easier for us to get everything in terms of the sign, which is the right side. Okay. So one procedure that we didn't use all that much was rewriting everything in terms of sine and cosine. All right. That would be a good approach to give a go here. So cotangent squared theta, if we rewrite that in terms of sine and cosine, we would utilize the quotient identities. Okay. So cotangent itself is equivalent to, so this would be cosine squared theta over sine squared theta. So you'll have a fraction within your numerator, which isn't ideal, but something that we will have to learn how to deal with. And then in the denominator, we have 1 plus cosecant theta. All right. Again, we're going to try to rewrite that in terms of sine, so that would become 1 plus 1 over sine theta. All right. Any questions there? All right. Now, what bothers me about this, besides, it looks hideous because we have fractions within fractions, right? So I want to get this denominator within the numerator to go away, and I want to get that denominator within the denominator to go away. Okay? So in order to get this to go away, I'd have to multiply it by what? By sine squared, right? If I multiply this by sine squared theta, in order to keep left side equal, then I would also have to multiply the denominator by sine squared theta. All right. Basically, what you're doing there is multiplying that numerator and the denominator LCD of what we have highlighted here. So if you look at this, I have sine squared in the numerator, right? And a sine theta in the denominator. The LCD between sine squared and sine is sine squared. Okay. So what will happen there is now we end up with this part canceling out, and we have cosine squared theta over, here we got to distribute this through to each part. So we got to distribute it through here and then here. So that'll become sine squared theta. And then 1 over sine times sine squared will be plus sine theta. Okay, any questions so far? Okay. So one thing that we always want to make sure that we do is keep an eye on what we want to get to. All right, we got to get to this. All right. So within that, we have everything in terms of sine, right? So a good idea would be to get this cosine squared rewritten as sine. So I'm going to go ahead and rewrite that as 1 minus sine squared theta. And I'm also going to go ahead and factor out a sine within this part. So this will become sine theta. If we take that out, and we'll be left with 1, or sine theta plus 1. Okay? So we're getting close. one issue here, I have sine theta plus 1, all right? That's got to go away, right? And we can get that to go away by hopping on the factor tracker. This is a difference of 2 squares, okay? We can factor that, like we did yesterday, into 1 plus sine theta times 1 minus sine theta, all right? And when we do that, we will have identical binomials in our numerator and denominator. This and that portion are the same. Remember, addition is commutative, so the fact that they're written in a different order doesn't matter. And we can see there that that left side is now the same as the right side, right? So that identity is verified.